Okay, so in this video we are going to talk about pointers and structures. So these are two very difficult topics in C. So do not hesitate to follow this class in multiple parts, to take breaks, to return to the class when you're doing your exercise, and don't hesitate to ask questions in the video comments. So to understand pointers, we have to have a bit of understanding about how the computer memory works. So it will be very easy. So here it's a representation of our memory. So each cell represents 1 byte, and each cell has an address. So here 0x 1001, 1002, etc. Okay, so here we know how to use that syntax. So we have a variable named A. It's a character, and it will be equal to the character A. So that will take a random cell. Random is important. And in that cell, it will add the code for the character A. So here in cell 0x1003, we have the character A, the code for the character A. So now we want to use pointers. So pointers are references to a memory cell, so like this. So here we're using a pointer, so I explained the syntax a bit better later. So that what it will do, it just it creates a variable p. It's a pointer on a character, and so it will create a cell in the memory. So in that cell, what it will add a value, a pointer to another cell. So here we will store the memory address of our previous variable A. So here 0x1003. So now you may think, okay, it's a bit difficult, but why? So something to understand is that, for example, if I take this line here and I change it a little bit, so here we have our A that equal to B. This won't change that cell. It will create another cell and add the character B to it. Up. Tuck, tuck, tuck. And but if you want to change that cell, specifically that one, we can do that, but by acting on the pointer. So for example, if we say, if we take that line here, and we say our pointer equal to, so the string of reference equal to C, for example. So this will change that cell right here. So here we have a bit of understanding of how pointer works. So pointers are not variable. If you want to print the value of a pointer, it won't print C, it will print this value. So the memory address of that of the pointer, of the value pointed by your pointer. Yeah, so that's it for this part. Now we will take a look at the code a bit more. Okay, so now that we have a better understanding about what pointers are, we'll take a look at what they represent when we were talking about string. So you are already used to that syntax So we have a character pointer A that we can also call a string, but in this class we will talk about character pointer because this class is about pointers, and that's equal to this string. This is just hello. We use double quotes because there are multiple characters and because it's a character pointer, not a character. Okay, so what does this mean? Okay, so if we take our memory, that means that somewhere there will be written the string hello, and following by a \0. The \0 only marks the end of the string, so that when we read the string, we know when to stop. So, and the A variable is a reference to the first letter of that string, the first character. So A is in this case an H. And we know, and for example, it's important to understand that technically technically A is just a pointer on an H. It's not a string because string doesn't exist natively in a C, or just abstractions, but that's a more advanced topic. And it's important to understand so that A is just a pointer on an H. We know that it's a string because we declare the variable A. We know that it's composed by multiple characters, so if we print it, we can print until we encounter a \0, but in the main process for C, A is just a pointer of the first character of the string, so here an H. Also something nice to understand is that we can use pointer as integers. So here we have another pointer that's called B, because I have a lot of imagination when it's come to picking variables names. So B is equal to A plus 1. What does that mean? Okay, that's very simple. We know that A is a reference to a variable. Here, A is a reference to this cell. This cell has this code, so 0x1001. If you add 1 to that number, it will give you this cell, 0x1002. That's magic. So that's mean that the B variable is this string. The B variable is a pointer to this cell. So if you want to print B, it will print hello like this. So that's it. That's the main point about how pointers work. For example, if you use that syntax, that's a bit different. You want to say that, for example, you want only to get a character, so we call it C, yeah. And you want to get, for example, the character with the index of 1. That will do this. So we have our memory. They will take the first character. So that means that technically it does exactly the same thing, except here we only get the character and here we get a pointer on that character. But basically it works the same thing, the same way. Okay, so now we will take a look at what it can look like when we code with pointers and string. Okay, so here we are in online GDB. So I will show you how to work with pointers using code this time. So here we have a simple main function, and we will create a function that will add 5 to a number, so to an integer. So usually what we do is we use this, so we take a function that will return int at 5. Okay, that will take another int as parameter, and it will return yes, that int plus 5. Okay, so now if I use this or here, okay, I want to print the number and 5. Yeah, we create in variable int I don't know, myvar equal 8, for example. Okay, and here I want to print the result of the function, so I do this, and it's correct. Okay, so here we got 13. So you should know, you follow the class and the functions, so you understand how that works. We have a variable, we pass it to a function, and we retrieve it here, and we return the sum of that variable and 5. Okay, so here it's the simple approach that works fine, actually. But here now we want to discuss about pointers, and we want an example with pointers, of course. So here we have another function with add5 pointer with pointers. Yeah, it's better name. So it will take not an int but an int pointer an integer. So I had a star here. That's very important. And we will return. Sorry. We will so to add 5 to now we don't want to return the value of the integer. We want to modify the parameter that is passed to the function. So here we will take take the value of the pointer, so it gives a star before, and say okay, it's equal to the value still of the pointer plus 5, or you can use that syntax if you like it better. I prefer that syntax. So now, how can we use it? So here we know how that works, and now what we do is call that function. That will take for parameter the address of an integer. So here we will take the address of my var. This way, for uppercase, yeah. And now we'll print the result. I just do copy paste this, and we just print my okay. Oh, sorry. And here, sorry, I forgot to yeah. Okay, so here we have two methods that add 8 to the value of my var. The only thing is that at this point my var is still equal to 8. It's not equal to 13 yet. But at this time it's equal to 13. So we have to be careful that the value has changed between this step and this step, the value of my var, because it has been used as a pointer. Okay, so this is the simple case. So now about the syntax, you might be a bit surprised, a bit confused maybe about the syntax, but it's very easy. Here we have an integer. Okay, so it's a number between minus 2 billion and plus 2 billion or something like this, and it's equal to 8. It's a simple number. If we want to have the address of that variable in memory, we use this. It's an ampersand character. Okay. That character is to say that we want to use a pointer on that variable. If you don't like the word pointer, you can think about the word address. It's basically the same thing, because the pointer is an address in the memory where the value is stored. Okay, so here we change, we take, okay, now we are in that function. Here we say we have, here we have an argument, a parameter for the function. That's an int pointer, because there is a star. Let's say we, what that means is that a, it's not an integer, it's the address of an integer. And also, if you prefer, you can write it like this. It's the same thing. I liked it this way, but that's as you want. And so a is not an integer, it's the address of an integer in the memory. So now we want to add 5 to the value in the address of the integer. So we have a, and we take its value. So with when you have a pointer, you want to get its value, you add a star before, and you add 5 to it. And now what you've done is, what say is, you take memory, you go to the right address, you take the integer, you add 5, and that's it. And here we don't have to return anything because the value has changed. So when you're here, the value of my var has changed, actually. If you want to run that function again, of course you will have 18. Sorry, my var. And here too. My mistake. Yes. Okay. Sorry about that. Okay, so now you understand it's the basic thing about pointers. So there is almost nothing that you need to know about that. That's basically the whole thing, and you won't need any more of that. Okay. Okay. So at this point, we now have another issue, is that we want to create a function that will return a pointer. So we made that function. So we have a function that returns a pointer to an integer, and that takes as a parameter the value that will be assigned to that integer if we want to create it. So we will use a local variable to store our value, sorry, not 5, and we will return the address of that value. And if we want to, we want to print the value of the pointer. And if we run that, we'll have a warning, and that's a very important thing. Okay, so what it say is that's actually an issue, a very big issue, that we want to return the address of a local variable from our function. As you might know from the other videos, if you have variable defined in a function, it won't be variable outside the scope of that function. For example, if for example you have here in that function you have an integer b equal 5, 26, okay, and you want to access this variable outside the function, you can't. You can because that's because when the function will be when the execution will be done, that variable will be deleted from the memory. But that's a problem because we need this function. It will be very helpful for some reason. So here it's a very basic example, but it can be very interesting. So the assertion doesn't work. Okay, so I will add comments to it. And now we write the right solution. So what we will do is we want to create a place in our memory that will stay there. So the way to do that is to use a function called malloc. So here we will have an integer that we call my pointer, because I have a lot of imagination when it comes to variable names, and malloc from, and here we want to say the space, the size of the memory that we need. So size of int. So that means we want to size of int just return the size of an integer. So if you want to know the size of an integer, we can print it. Actually, that's not the point here. And what we can do is we say my pointer. Now it's my pointer is contains the address of a place in memory where we can store the value of an integer. So now what we can do is say, okay, so in the value, in the value of that address, we will add 26. Okay, and we want to return my pointer. And if we run that, we have a problem, because a malloc is undefined. We will need to online GDB is quite nice because they say exactly the problem, the issue here. We forgot to include std lib for a standard library. So here we can add it. I also forgot the semicolon here. And yeah, that's it. Okay, so if I add it now, I run that, there's still a problem. Yes, sorry, size of. It's a function, I think. Yeah, sorry. So size of is a function. I thought it was a keyword. It's too many other language, too many languages at the same time. So okay, so now we have that value. We have absolutely no warning, and we can actually use that variable here. If you want, for example, to add. Sorry, it's not 26. It's value. My mistake. Okay, so if for example we want to add 5 to the variable, here we will have 10, of course, because yeah, we can access that memory. But there is one thing that we forgot. Because that space in the memory will not be deleted at the end of the function, because we say, okay, we want to allocate it. The word allocate is very important. That's the conventional word for that. And okay, so we allocated this memory space, but now we want to free it when we don't need our variable anymore. Otherwise, the space in the memory will stay there, and we won't be able to. And it will always take some space. So here it's a basic integer, so that's not a lot of memory. But if you have a table with 256 elements, or I don't know, big structures or variable, or a lot of them, it will start to take a lot of your memory. And if you have, even if you have a very powerful computer, if you have a big process, it can be a problem. So to do that, the only thing that you need to do is call a method called function called free. Here, and pass it your pointer. That's it. After that function, the memory allocated by that pointer will be destroyed, and you won't be if you so at the end of the function you won't be able to access that memory freely, actually. So, and it doesn't change how the program works. So that's a mistake that we all made sometime, is to forget that function. But because it doesn't change how the program behaves, but it changes how the memory is allocated. And so the problem is, if we forget that, our program will take a lot of memory, and we won't have anything for our new variables. So that's a problem, of course. Okay. At this point, you might wonder why is this useful? Why anyone will be using pointers for any reasons? But there is a very simple case that maybe you already know, or maybe not, but I will show it to you. It's when you work with standard outputs. Standard input, sorry. As you know, your program will output can output things. So you can write in some files. You can write in the console. You can send API calls for anything. These are called outputs, and it can also take inputs. So, for example, when you run a program, you can you can run it with arguments, or you can read information from the terminal, or you can read information from the file of the web browser, or anything. And for all these cases, for the input, you will need pointers, because you will always be in a situation where, okay, you want to get something and you want to store it somewhere where you can access it. And this step, you must use a pointer for that, because you need to say where this information will be stored. You need to specify in the memory where it will be stored, so you need a pointer to represent this space. I wrote a very simple example here. So it's a very basic program. Where you will have, let's center it a bit. Okay, we are our main function. We'll create an integer a. We don't need to give it a value now. That's not important. We print this, and we will use this function called scanf. Scanf will read something from the output and add it to this in that address. So here we want to say we will add it in the address of A. So that means, okay, so we will have our input in the console, and if we write any number, it will be added at the value of A. So, very simple demonstration. I'm sure you will be amazed by this. So I will write number. Okay. So and here, when we print the value of A, you see we get exactly the same number. Of course, you can manipulate it or do anything that you will normally do with a variable, and it will work just fine. So this is a very simple case, a simple use case that you can use to when you have some variable. When you need to get some data, and you want to store it somewhere in your memory, but you don't know the exactly what data you will put there. Okay. Of course, this is only a simple use case. There are a lot of use cases from pointers. a lot of languages work only with pointers, for example Java. In Java you don't have all the syntax when you write variables. For example, you don't have the star, you don't have the ampersand, you don't have this. Because it's all implicit. When you use variable in Java, you have two possibilities. Either it's a primitive type, sorry I forgot the word primitive, like integer, like boolean, or like a character, for example. And in that case, there are not pointers. In every other case, there are pointers. And most of modern programs remains on rest on pointers, actually, because they made stuff very easy. Right now you might think it's a bit hard, but do the exercise. Don't hesitate to practice, to go back to this class, or to ask any questions. I'm sure you will understand everything in the end, because that's not that's a topic that that seems to be hard, but that's not hard at all.